Good afternoon, everyone. Welcome back. Now, as we step into the afternoon session of Day 4 of our Faculty Development Program, it's my pleasure to introduce our distinguished speaker for this afternoon session, Dr. Amit Kumar Vishwakarma, who is currently serving as a postdoctoral researcher at Khalifa University, UAE. Sir holds a PhD in electrical engineering from IIT Kanpur and Tsinghua University, China, along with an MTech from MNNIT Allahabad. His academic and research journey reflects deep expertise in artificial intelligence, machine learning, blockchain technology, and digital systems. He has contributed to several impactful projects integrating AI and blockchain in areas like sustainable energy management, public procurement, and supply chain transparency. His research has been published in reputed international journals, and he has delivered invited talks at eminent institutions such as Tsinghua University, O.P. Jindal University, and the Ministry of Finance, India. Today, he will be sharing his insights on Web3 usage for blockchain. Now, I would like to invite additional head of AIML department, Mr. Abhishek Shukla sir, to present the token of appreciation to our esteemed speaker. Let's give a warm welcome to Dr. Amit Kumar Vishwakarma sir.
Okay, so first of all, I would like to thank you all. Okay, so you have been here for almost 4 days, right? For 4 days. Okay. So I assume you have learned a lot about blockchain. So first, I would like to ask a question. Anyone like to explain what is a blockchain? Or anyone would like to explain why we are studying about blockchain? I mean, why this technology? Anyone wants to explain? Any student? Anyone? Sorry? It requires more security or it provides more security? So just about the security or any other aspects of this? Decentralization, immutable ledger, any other thing? And how it is more secure than the general one? Like we already have cyber security, right? Why we are studying about the blockchain then? Okay. Okay, that's great. Anyone wants to say about the formal definition? What is a blockchain? Suppose you have to explain the blockchain about like to a first year student, okay, who don't know about any technology, who just came fresh, and you want to explain him what is a blockchain. What you would like to say? Okay, we have banking system, right? We do have a banking system. We have a ledger, bank control, all the things. So we'll discuss about first the Bitcoin, why, like how it started and why it started. Then we'll come with the real-time problem that I am working, that I would like to share with you all. Okay. So basically the one you said, distributed ledger, immutable properties, and we have a hash encryption algorithm, that is a one way that provides a security, and we have a traceability also, right? So these 4-5 properties that holds a blockchain, and that's why we are studying about the blockchain. So it is not a new technology. Like I would like to say, it is not a new technology. We have a mix of technology. We have 5 technology that is mixed up, and someone created a Bitcoin. So you people know the paper, the one introduced the Bitcoin. Satoshi Nakamoto, right? That person name. So the paper was, anyone would like to, anyone have read that paper? No. So this one was the paper that introduced the Bitcoin, okay? So Bitcoin, a peer-to-peer electronic cash system. So I don't know if you people can see there, okay? So in this one, he introduced four or five, like five technologies he mixed, and then he created a new system called a Bitcoin. So for a peer-to-peer transactions, okay? So what is a peer-to-peer transaction? Anyone would like to say? So we have UPI right now, right? So you are making transactions. Suppose you are sending money to your friend. So what happened in that process? What is the whole process that bank follows? You know, right? You initiate a transaction. You initiated a transaction. It will goes to a bank. Bank will verify. Suppose you have money, like you have enough money, and the receiver is genuine. Then it will transfer the money to the other's account. So there is a bank in between. Okay. So the Bitcoin, this paper came and it eliminated the bank from the existence. Okay. So now you can directly transfer money to your friend. So that is, we have a Bitcoin. That's why we have a cryptocurrencies. A lot of cryptocurrencies, right? Bitcoin and Ether and Solana, other cryptocurrencies. That is peer to peer. Okay. And then if we'll move. Okay, so that's how it got introduced, and that's why we are studying about this. Okay, so it is like when it started in 2009. So the main application was cryptocurrencies, but right now we have like multiple application, and one of the such application that we'll see right now. Okay. So the topic we'll cover today is blockchain enabled peer-to-peer renewable energy trading. And we'll see about the markets, how the market is in India and in the world, and then we'll do a hands-on on carbon tokenization. Okay. So we'll create a carbon token. So we'll develop a smart contract in our hands-on session. Okay. So the basics will start. So we'll introduce the topic. We'll see a little bit about the blockchain, then how the peer-to-peer renewable energies trading can work, and then carbon tokenization, and then how we can introduce the AI and Web3 into the energy, and what are the research and policies in India and in the world that people are following for this one, and then we'll have hands-on training. So anyone know about renewable energies? So what are the markets, and how we are moving from the traditional one to renewable one, like non-renewable, sorry, from renewable to non-renewable? Yeah, please. Okay, non-renewable is solar panel, okay, yeah. And the others? Wind, hydro energy, okay. Other one? Nuclear. Nuclear is not non-renewable actually. Okay. Okay, so why we are moving from renewable to non-renewable? Anyone would like to say about that? So we know, right? Non-renewable energies, they are very limited. Okay. And that's why we need renewable energies. So right now there are certain initiatives taken by the governments, like the Indian governments, and in India we don't have too much renewable energies, but I was in UAE, most of around 30-35% energy comes from renewables. Okay, comes from solar panel, comes from wind energy. Okay. So why we are moving from non-renewable to renewable? Okay, so non-renewable is centralized in nature, and we need to shift into the decentralized clean energies. Okay, so we'll take an example of this one. Okay, you have solar panel in your college. We have, right? Anyone knows how much it produces? No? And what is the consumption of the college? No? Okay, suppose we'll take an example, okay? So at like anyone's, at your home you have solar panel, right? Most of people are having solar panel right now. So the amount you are generating from the solar panel, the consumption, both are not equal. Okay, sometimes you are generating more and sometimes you are generating less, depending on the users, the users of your house. So have anyone thought what happens to the excess energy that you produce at your home? Sorry? To third party? Okay, we have a system right now, so you people don't know about the methodology, but what happens, the excess energy goes to the grid. Okay, so the grid is not at your home, grid is around 30 to 40 kilometer away from home, depending on the rural areas or the urban areas that you are staying. Okay, so anyone from electrical background here? No? All from computer science? Okay, so okay, you people know the process, right? Energy generated from the grid and it comes to your house. So anyone know the transmission and distribution losses that happens in between? The transfer of energy happens from the grid to your home. So there are certain amount of losses that occurs in a electric wire. You have seen the electric wires, right? So the losses are too much. Too much means it is around 17 to 20% transmission and distribution losses. So what are we trying to do here? So the problem statement is we are trying to negate that losses. Okay, we are trying to reduce that losses. So how it will happen? So to reduce that losses, you don't need to sell that excess energy to the grid. You can sell that excess energy to your neighbor. Okay. So what will happen here? So first of all, you are reducing that transmission and distribution losses. Second of all, second thing is you are creating an income for yourself. Like the excess energy, you are not losing that and you are selling that energy to your neighbor. And you can decide the rate because it is peer to peer. So you can decide the rate, how much you are charged for that energy. And there will be a less dependency on the utility company. Like we have a PGCIL and the other companies we call the utility company, and there will be a less dependency on those companies. So this will create a system so that can be adopted in a village or in a city, and you can be a self-sustainable city. You can produce your energy, you can sell your energy, and you can be independent from the non-renewables. Okay, so that is the problem statement. And my question is how blockchain can be fitted into this. So you have attended 4 days session, right? So how blockchain can be fit into this one? Anyone would like to say anything? How we will introduce the blockchain into this problem? Okay, we said someone said, right, we have 3 or 4 properties of blockchain. So how those property can be fit into the peer-to-peer energy trading? Just try to think about this one, okay? Sorry? So we need to create a blockchain network between the peers, okay? So what we can do, the excess energy you can sell to the people, that will go through the transmission wire, but the transaction will happen through the blockchain, right? And you can check the supply and demand, how much is supply and what is the demand. Based on that, you can create the smart meter. The smart contracts is a different thing for the exchange, okay, that will happen between the prosumer and consumer, okay. So this is the India's vision for the clean energy. So we have a target of 500 gigawatt by 2030. I am not 100% sure they are going to achieve this one. We have a net zero emission Net zero, anyone have heard this word net zero? What is net zero? Sorry? Zero carbon footprints. Okay, so what is like meaning of zero carbon footprints? Okay, there are certain amount of carbon that get produces every day. Okay, and to negate those carbons, we have certain, like we have why people say like you need to plant more trees. So the trees absorbs the carbons. Okay, so the amount of carbon that you produces and the amount of carbon that absorbed by the plants, so you need to negate those things. Okay, because right now we have the production is, I'm not sure, but it is 5 or 6 times more than the consumption. Okay, so this is like in India we don't have this much this market, but in European countries or in the developed countries the market for carbon trading is huge. So they have certain policies that you need to maintain this much carbon credits. So we have industries in India. So like most of the carbons are produced by the industries. Okay, so they don't have any policies to negate those things. But in European countries and in the Western countries, we have these policies. Like the amount of carbon you are producing, you need to find a solution to negate that carbon. Okay, so what they do? Suppose there is a company, they are producing very small carbon credit, so a very small carbon, so they can sell those carbon to the other companies, so that they can maintain the carbon credit ratio. Okay, so that carbon credit trading also can be happened in the blockchain. Okay, so that is the another one. So I am trying to fit the blockchain into this one. So what I have done so far, that I will try to bring it here. Okay. So this is the traditional flow that we people know. So there is a generation, then we have a grid, grid to home, okay, home to utility, like the consumption that we are doing. Okay. So the blockchain, so what will do the blockchain here? So we are producing energy from the solar panel, then it will go to the smart meter, the one we have into house, and then on a blockchain, so we can create the smart contract for the transaction, and we can create a bidirectional energy transfer to the households, and then there will be a token. So cause you need to create a cryptocurrencies for that, right? Token means what? Token means cryptocurrencies. Okay, so you can create a token for yourself and you can distribute that token. So how this token works? Anyone knows about this token? So you get the token on the shop, right? So how that token works? Suppose you are going for a sweet shop, they will give you a token, and by using that token you can get the items, right? The same concept goes here also. So the network will produce the token, so the amount of consumption that will happen into the network, so based on that they will create a token, and you will get the token. The token will have a certain value, like we have 50 rupees token, right? So that token will have a certain value, and using that token you can buy the carbon credits, or you can trade the carbons, okay, or you can trade the energies here. Okay, so you know this all the cryptocurrencies, they are tokens only, right? One Bitcoin holds certain value, one Ether holds certain value, one Solana holds certain value. Okay, so those cryptocurrencies are also the token, and you can create your own token. I will try to do something here today, so we cannot do that much because we don't have too much time. We have only 1 hour. But if you want to create a token, you can create a token by yourself. Okay, you can create your own cryptocurrencies and you can distribute into the college. So you can create a system within your college. Okay, a blockchain network basically I am trying to say, and through that network you can do the transactions. Okay. So the challenges that we already discussed, okay, so there are centralized generation and control, so we will have some problems. So we have transmission and distribution losses, and we have a complex billing and settlement, because nowadays you people here, someone got the bill of 2 lakhs, 3 lakhs, 5 lakhs, 10 lakhs, and they are using in hundreds, right? So that problems happen because there is a lack of transparency. Okay, so the blockchain will give you a transparent system. So you can check how much you are using and how much bill is generating. Okay. And we have a threats also. In India, we don't have cyber security threat because we are not fully online into the grids. But in European, you people have seen the movies, right? In movies, some hacker will come and they will control all the lights, and that actually happens in European countries. Okay. In India, we don't have that much. We don't have that advanced thing, but in European countries we have. Okay. So what is missing in this one? A secure and transparent, automated and decentralized system. Okay. So we will not go more into the energy things. We will come to the blockchain one. Okay. So a little bit concept. So I am not sure you people can see these slides. Is it visible to you all? Sure? Okay. So there are few terminologies that I will discuss, then we will move ahead. Okay. So there is a 4 terminologies here. So one is consumer, one is prosumer, one is microgrid, and one is utility company. So what is the utility company? The utility company is the company that provides you electricity. Okay. Like we have a PGCIL and NPCL, all those companies are utility companies. They provide Reliance Power. So they are the utility companies. Then we have a microgrid. So how much total grid we have in India, you people know? Few years back there was a blackout. So one grid got failed in North India. Okay, whole North India was a blackout. I am not sure you people know about that. We have almost like total 7 grids in India. Okay, the main grids. So after that main grids, in one grid there will be sub grids and there will be microgrids at your house. Okay, so you know the transformer, right? Those they are the kind of grids only. They control the electricity. Okay, so there will be 11,000 volt, and then you will get 230 volt to your house. Okay, and then we have a consumer. We are the consumer. Prosumer, the people who produces also and who consumes also. We call the prosumer. Okay. So why blockchain? For the energy that we discuss, for the billing disputed, and for the transparency, and we'll remove the central dependency. We'll try to build our own system. We have certain system in the world that I will discuss in real case example. Okay. And we can create our own coin, and we can decide the value, and we can do the transaction. Okay. The blockchain solution, blockchain will provide the immutable system, and we'll have a real-time settlement called smart contract settlement, and we'll have a distributed trust. So you don't need to trust anybody. So you can rely on the blockchain network, and we can create a token. Okay. So this is the full plan that we'll discuss. Prosumer will generate the energy, smart contracts, measurement, and then meter science, and then we'll have a data on a blockchain node. Okay, so you people know, right, what kind of data blockchain stores? Hash value. Okay, so what happens to the data? If blockchain stored the hash value, what happens with the data? Where it got stored? Database? Which kind of database used in blockchain? Sorry? Sorry? So that is a format. Where is the data stored? We have IPFS, right? We have IPFS that we generally use for permission blockchain, and we have Oracle also. Okay. So they store the data, then we have a hash value, and that hash value gets stored on a blockchain. So the transaction doesn't really happen on a blockchain. Okay. It happens through the logic, the one we have. Okay. And that after transaction gets completed, the hash value of the transaction that gets stored on a blockchain. You know that, right? That process. You have seen that in maybe in the basic one if people have discussed here. Okay. You know the Merkle tree, hash value Merkle tree, right? So the transaction happen through the Merkle tree. So the same thing goes with our energy one. So we cannot store all the data on a blockchain. So we need to have IPFS. That will happen centralized here, because we are not building a full-fledged one, because we have a certain limitation. We are having 100 household or 200 household. So for a demo purpose, we will have a centralized one. Okay. So this is the basically concept that will follow. There will be a smart contract, and that will have a transaction logic, and then we will do the transaction through between the prosumer and consumer. Okay. This one I took from one of my paper. So if you want to build a system, so it doesn't include only renewable energies. To build any kind of system, any kind of application, if you want to build, you need to follow this one exactly. Okay. So I cannot see there, so I will see, I will read from here. Okay. So the first one, here we'll have a user, prosumer, utility company, and energy generator, and auditor, smart meter, and DSO. So on the top one. Okay. So if you are taking any kind of example, any kind of problem, so there will be a user on the top, and then we'll have a decentralized apps, and then after that you will have a APIs, and then we'll have a energy trading smart contract, or like smart contract, just say the smart contract, and after that we'll have a Ethereum ledger. So based on the blockchain, the one you are building, maybe on Ethereum, or maybe on a Hyperledger, or maybe on a private one. I like the consortium blockchain. You can take any kind of blockchain here. Okay, but the data will store on the IPFS. Okay. Okay, so there are 2-3 words if you have heard previously, or I will discuss. You know the off chain? Anyone knows the off chain? Anyone heard off chain during the sessions? What is off chain? So what actually we have a problems in a blockchain also, right? That's why blockchain is not the solution for everything. So you know that problem. Anyone knows those blockchain trilemma? We have basically three problems in a blockchain. Okay. Sorry. Sorry. In a blockchain? No, it's not slow, because you are not searching in the data actually, you are searching in the hash value. Okay, so data is already stored on IPFS. Based on the hash value, you can get the data easily. So the blockchain trilemma is decentralization, security, and scalability. Okay, you know this one? So what is the scalability in this one? You know the word scalability? What is scalability? Basic example I will take. Suppose around 30 or 40 people are here. So suppose 20 people came again, okay, from outside. How you are going to accommodate those 20 into this in these seats only? Okay. So this is kind of a scalability problem. You are trying to scale the population here. Okay. So 20 you can accommodate here, but if you will get the 50 here, then what you will do? So you need to find another room, right? So that is the scalability problem in a blockchain also. So all the transaction cannot be stored on a blockchain, because you know the blockchain is very costly, right? It is not cheap. So that's why not everything happens on a blockchain. The Bitcoin is okay. Bitcoin, they have a larger value, and they the value of Bitcoin is too much, so they can do easily. But suppose you are doing the energy trading. So energy trading cannot happen on a blockchain, like on a main blockchain, because the energy, the kind of energy you are producing, that is not too much, right? The amount is not too much, and you need to sell that one. So if you are going for a blockchain one, on a main blockchain, then you cannot, you will not get any benefit, okay? Even you will lose the money into the process. So we will have a process called off-chain. It will not be on a blockchain, okay? It will be off-chain. That is also a blockchain that you create by yourself, okay? And the data of that off-chain blockchain will go to the main blockchain, okay? So that is called off-chain. We have certain examples for off-chain. Like we have a latency network is very famous, and latency network. Okay. Off-chain. Actually, I have worked on latency only, and I created, actually I was in the part of that, and you know the Polygon. You have heard the Polygon, right? That is also the off-chain that is built on the Ethereum. Okay. So off-chain means it is on, there is another blockchain on the main blockchain. It can be built on a Bitcoin also, it can be built on the Ethereum also, or it can be built on the Hyperledger. You know the types of blockchain, right? There is permission and permissionless. Ethereum and Bitcoin is a permissionless, and we have a permission blockchain in a Hyperledger. Okay. So Hyperledger is a type. In the Hyperledger there are certain Hyperledger Fabric, Hyperledger, and there are certain other blockchains. Okay. So we'll have a 4-layer here. We'll have a physical layer, and then we'll have IoT metering. Because the data you will get from the IoTs, right? IoT devices, you need to include the IoT devices if you are reading the data from the smart meter. And then we'll have a blockchain. So here blockchain, we are talking about not the main blockchain. Blockchain is a general terms of the blockchain. You can use any kind of blockchain. You can use the Ethereum or Hyperledger, okay? And then we need to build a marketplace, a UI, okay? Because the people, they are not going to do the transaction on a blockchain. They need a certain kind of UI, like we have in UPI, right? So this is the process that will follow. Prosumer to meter. Meter goes the hash value. Hash value will store on a blockchain, and then there will be a smart contract. Then token will be produced, and then it will go to the consumer, and there will be a settlement. Okay. So this is the process that we are going to follow in our smart contract. Okay. So we'll have certain assumptions like the energy tokenizations. So 1 kilowatt is equal to 1 token, 1 energy token. So this is for our implementation, I have taken this one. So it is not the actual one because we don't know the token value. So we cannot decide the token. But for our implementation, we have taken 1 kilowatt is equal to 1 energy token. Okay. And then the purpose will be the same, the energy trading and automated settlement. Okay. So you know the token, right? Fungible token, non-fungible token. Difference, anyone knows? Fungible and non-fungible? No? Okay. So any kind of token, you know, ERC20, ERC1155, no? So the Bitcoin concept is built on the ERC20, that is fungible token. The fungible means, suppose you have a 100 rupees note, right? And you also have a 100 rupees note. You can exchange those notes, right? It won't affect the value. Okay? So this is called the fungible one. Means the certain amount of token will have certain value, and the same amount of token will hold the same value. Okay? It is not basically, it is interexchangeable. Okay? And in the non-fungible token, anyone knows the NFT? What is the full form NFT? Non-fungible tokens, right? So what is the unique property of NFT? Suppose you take your image, a digital image, and you can build the NFT on that, okay, of the image. You can store the hash value of your image, and you can put it on a blockchain, and you can make it on an auction. So that is the NFT process, okay. So the property of NFTs is, you cannot, suppose you have another image of yourself only, but the same hash value, like the hash value will not be the same, okay. So the image, the previous image will have the same hash value of your same image. If you are taking your another image, the hash value will be different. That means it is not interexchangeable. That is called the NFTs. That's why people use the copyrights for this one, okay. So basically NFTs, the main use of NFTs is for the copyrights. The music, like when it started, people started using in the music industries, very happily, okay, for the copyrights of the music. But we are not going for the NFTs, we are building the fungible token here, okay, like ERC20, because all the tokens will hold the same amount of value, okay. So that's why we'll build here ERC20. Okay, so this is my interest, like my favorite topic. So called the consensus mechanism. Anyone knows about this one? Anyone have heard the word consensus? Anyone? Sorry? To get the conclusion? Okay. In a simple term, suppose all of you decided to do something, okay, to reach to a conclusion. That is called the consensus mechanism, okay, to reach a consensus, to reach a common goal. So what is the role of this, like you know the definition, right, consensus. What is the role of this consensus in the blockchain mechanism? Please. Don't go to the minors, we'll come to the minors. Like in a general term, what is consensus doing here? Well, like, okay, so what are the minors here? Add data to the blockchain, okay. So there are certain rewards for that in a Bitcoin, okay. Okay. So what is the consensus doing here? Like what is the role of consensus here? Can you speak louder, maybe little like other people? Okay. Yeah, right. Hmm. Not good or better, they have better resources. Okay. Hmm. One who solves first will get the chance to add the block. Okay. Okay. So that's nice. Okay, so we have a consensus mechanism here. So basically, in a blockchain, as I said, there is a no centralized authority to do the transaction here, right? It's the people who are doing the transaction, and it's the people, like people means node, computer nodes, okay? It's the people who are verifying the transactions also, okay? So how you will decide who will verify the transaction? So there are certain kind of people, certain sets of people that will reach to the conclusion. So I am trying to match the definition, the one we said. So they will reach to the conclusion, like this is the person that we are giving the chance to add a block into the blockchain or to verify the transaction that is happening into the blockchain, right? So that's the process of consensus mechanism. So the basic, like the first one, we have a proof of work that used in a Bitcoin, okay, because this is very computationally very expensive actually, okay. So that's why we use only Bitcoin and Ethereum and no other example of POV, okay, proof of work, okay. But that was very complex, the complexity was too much, like you need to, okay, I have seen this one, okay, I was in Beijing, China. So they have a certain companies that are doing the mining only. In a Bitcoin mining, the reward is too much. Right now we have 3.275, if I am not wrong, okay, 3.275 Bitcoin to mine a block, single block, okay. And 3.275 Bitcoin will hold in Indian rupees 3 crore rupees, okay, itna paisa. So for that they have companies, okay, not one companies, there are like multiple companies in China, they are working on this mining process. So for the miners, they will have machines as big as this room, okay, even bigger than this room. And what are they doing? They are just trying to solve that mathematical puzzle that is given by the Bitcoin, okay. So that is a proof of work, but that will not use in our system because we We cannot afford that much computational complexity, right? But to reduce that computational complexity, we have another one called proof of stake. So right now, if anyone knows about the Ethereum, Ethereum is trying to scale and they are trying to come on the proof of stake. Okay, they have been trying since almost 3 or 4 years, but they haven't reached it so far. Once they will reach, it will become more faster and it will become more prominent than a Bitcoin. Okay, and then we have a PVFT. It's called a practical Byzantine fault tolerance. I am not going in detail with this one. Okay, the PVFT is used for low latency, okay, and for very less energy users, and it is best for the local grids. Okay, so the first one I developed on a PVFT. Okay, and then we have a proof of authority, POA. So that is the utility supervised microgrids, but this is not for our projects. Once you are going to deploy in a larger scale, then we can move from PVFT to POA. Okay, proof of authority means there will be certain people who will be responsible for adding the blocks. They will be responsible for the data. Okay, like we have in a government. All the data are centralized, but the data will not be centralized. That will be a decentralized, but not into the data will be distributed, not decentralized. Okay, distributed means there will be certain people and the data will be distributed among them, and the other people, they will be just users. Okay, so it will be hard for the government to change the data also. And I will give you one example. I should not give this one, okay, but I will take an example of any college. I will not give the college name. Okay, so there was one person who did PhD in 90s, like 95 or 98. Okay, and his thesis was submitted. So right now you submit your thesis in a hard copy, right, in the final year project. So same we have in PhDs. PhD you need to submit a thesis in a hard binding copy, and that hard binding copy will go to the college library. Okay, so in the library there will be archive and it will be deposited into the archive. So after 20 years he did his PhD and he got job in the same college. After 20 years he got into the fight with the with other people, and they were little bit more powerful than the other guy. So what they did, they asked the question about his thesis, because his thesis was plagiarized. Okay, the thesis had like the work of someone else. It was not the genuine work of his PhD. So, and this is very serious offense. You can get terminated from your job. So what they did, the person whose thesis was submitted in the library, they did some work, internal work, and they changed the whole thesis. Okay, now you have a new thesis, and new thesis was a little bit better than the previous one. So this kind of problem, this is the one problem that I know, but this is a very general problem in the academics. Okay, in the big institution, I don't know about the PhDs here, like how people are submitting the thesis. But right now, all the big institutions, what they have adopted, they started submitting the thesis on a blockchain. Okay, so what you can do, you can take the soft copy of the thesis, and you can take the hash value, and you can submit it on the blockchain. And all the property that we said, it cannot be tempered or it cannot be changed later. Okay, it can be there for hundreds of years, and no one can change the thesis. Right now, people started giving degrees also. So what will happen by giving the degrees on a blockchain? So no one needs the physical verification of the degree. You can just check the hash value and it will show you the originality of the degree. Okay, you cannot change the degree also. We have certain fake degrees also, right? You have seen the Modi's degree, right? So I'm not commenting on the fake or the original one, but yeah, you cannot change those things. Okay, once it is on the archive, it cannot be changed. Okay. So you can decide your own pricing model also. So the pricing model means like what will be the price of in the time of day, like we have, right? So right now we have if you are ordering food, okay, on Swiggy or Zomato, so there are surcharges, right? in the peak time they will have surcharges, or you are booking a cab, so there will be surcharges in the evening time, and in the daytime it will be less, in night time also it will be less. The same concept also we can use here in the system, okay, if you are building this one. So you can decide the pricing mechanism, and we'll have a real-time market pricing because it is fully transparent. So the price you can see in actual time, and then you can decide like if you want to buy the electricity from your neighbor, or you want to buy the electricity from the utility company, okay. And then we'll have a bid ask auction, so you can do the bidding. I want to do this one. Basically you want to negotiate, and you can do the negotiation here also, okay. So in this one also you can do the blockchain traceability of energy losses. As I said, 17 to 20% of the energy losses happens in transmission and distribution. So you can really trace that one, and you can find the hot spot, and you can take the measurement, and you can try to avoid those losses in the centralized system, okay. So you can do that also, and the other things are same as a decentralized one. Okay, so this is the design that we'll do right now, okay. So we'll take a solar panel example, and we'll have IoT devices data, but I am not going to build IoT devices here. I will just take the data, and we'll have a digital signature. Okay, what is the meaning of digital signature here, and how is it different from the signature that you do and you take a picture and you paste it on a PDF? Private key and okay, that is okay, but if you want to explain to the other people, how you will explain the difference between the digital signature and okay, okay, right. Hmm. That is okay, but not the fully one, okay. Basically it involves the encryption mechanism also, okay. So why it is digital signature used in a blockchain? In a blockchain everything happens through the hash value, right? So the signature you did, and you take the hash value and you store it on a blockchain. The process is same, the one you said, public and private keys, okay. You store the hash value on a blockchain, okay, and you can verify the signature through the hash value, okay. You can, suppose you are trying to copy the signature, you can copy exactly 100% of the signature, but the hash value will not be the same, right? So that's how you verify the digital signature. In a PDF one, you can write a signature, okay, and you can duplicate that signature, and again you can post it on a PDF copies, okay. So the difference between the digital signature on the blockchain and the digital signature that happens in a PDF copies, the difference is this one, okay. So you can say the main property of blockchain is what? Because it is stored the hash value, right? You know that process, right? The boxes, how it is stored the data on a blockchain. You people know, right? The block 0 starts from here, block 1, block 2, block 3, and it goes to till here, okay. If you are changing the data from this block, and there is certain transactions like this one, okay, this is in thousands, okay. So this is transaction 1, transaction last TN. So if you are changing the single transaction here, then it will change the whole hash value of the whole data, okay. So that's why it is it can be a tamper proof data, okay. And why you remember the blockchain trilemma: scalability, decentralization and security, okay. So why the decentralization needed here? Why we say that we are building a trustless system? What will happen if we will build a trusted system? What will happen if we build a network among ourselves? No, the problem is, sorry, what you said? Yeah, yeah, yeah. So, why I said there can happen this one, okay? Because okay, I'll show you data, okay? So, look at this data carefully. Can you see this one? I'm not sure if this is visible to you guys. Is it visible to you guys? Okay, you can see this one, right? This is the 100% of mining companies in the world. Okay, and there are, if you will include this only these three companies, then it will hold around 70% of the mining power of the Bitcoin. Okay, if they collude, if these three companies, if they collude, what will happen? The power will become like power will goes to a single person. Okay, a single company will be so powerful they can change the whole transaction. Okay, and why is it not possible in the blockchain? Because if you are changing even a single transaction, everybody will know in the network. And then why they are not doing that also? They can do actually, but they are not doing because if they will do that, the trust of the people in a Bitcoin will get lost and the value of Bitcoin will be zero. Okay, like we have a certain other examples like Shiba Inu, if you have heard. We have other cryptocurrencies, the value suddenly goes to zero. Like the Dogecoin, you know, Elon Musk, he was crying about this one, the Dogecoin. The value will goes to zero. Okay. I'm pretty sure you people can't see this one also. Okay, this is also one from one of my paper. So the DSO is digital system oscilloscope. So this is the same DSO that we use in our lab. Okay, so this holds the readings and meters, parameters of the smart meter. Okay, so then we have a prosumer and consumer. Then we will have a smart contract and IPFS. Suppose you are building a system, so before building a system you need to build this one also. Okay, so this one will hold all the steps that you are going to take into the process. Okay, so first what you are going to do, you are going to deploy the smart contract, and in the smart contract you will register all the stakeholders that are into the nodes, and then we'll have a node registered, and then we'll have data into the IPFS, and it will return some value. So this is the process that will happen. Okay, I will show you in the real time smart, like when we'll do the smart contract implementation. Okay, this will happen here. I can share this one, you people can see if you wanna work in this one. Okay, okay. So what we are going to do into the smart contract, so we will do, this is a simple coding, the one you do in any other languages. Okay, you build a what we say, high level, you write a high level code, like the concept, the algorithms for that one, then you code to those logics, the one basically I am saying. Okay, So the logic is here, first you are going to register prosumer, then there will be a meter reading like if there is excess energy or not and if you want to sell, and then you will find a match for that trade, the one you want to do, and then you will transfer the token and then there will be transaction happened, okay, and at last you can check the losses like how much you generated and how much you transferred, okay. All this can be done through the smart contract that we are going to do, okay. So the register node, what you will do, it will register the prosumer, consumer, DSO and smart meter, and the mechanism it will follow. So it is little bit going to the core one like public key, identity issuance, then whitelisting, and then there will be a role assignment for the nodes like the what prosumer is going to do, what consumer is going to do, and what DSO will do, and what is the smart meter doing here, okay. The outcome will be, so we will have a secure on-chain identities that will prevent the basically meter damage, okay. Then another one, so after node register, then we will have inject energy. So we will inject energy into the, where we are injecting the energy here, into the blockchain network, the one we have created, right. We will inject the energy into the network like this is the excess energy that I am trying to sell, and this is the meter reading, and this is the timestamp, and this is the meter signature hash. Like this is like we have a single node, and this is the node signature and timestamp and the meter reading and the price, that amount that you have set for the selling that energy into the network, okay. So you know the hashing algorithm. So SHA-256, I think it is not new to you guys, okay. So what is the difference between SHA-256 and 512? We have another hashing algorithms, right? So what are the other hashing algorithms? Yeah. It is basically if you are increasing the bits, what will happen? The combination of hash value that will generated will be 2 power 256, okay, in the SHA-256, and 512 it will happen 2 power 512, okay. So the number will get increased, the combination will be more, and the chances of collision of hash value will be very less, okay. So right now we have, it is like we have I think 1 by 1 million chances is there that a hash value will match to the another hash value, but in 512 it is again like very less than the 1 by million, okay. So we'll have energy injected into the network, and then we'll match the nodes, the prosumer and consumers, between the transaction is happening, and then there will be available energy, bid or ask price, and the locality constraint. If it is in your locality, you want to transfer the energy to the person or not. And then we'll have matching methods. Matching methods can be coded into the smart contract, okay. Then we'll have the event emitted called prosumer and consumer matched. Then another one will be energy trading, match energy and execute trade. This will happen into the single one. And then we'll have transaction verification. Transaction will get verified, okay. So there is one more terminology that I'm not able to recall. So you know the transaction is not a real-time transaction in Bitcoin. It's not a real time, right? So it takes certain times, around 10 minutes to complete a Bitcoin transaction, right? So where this value gets stored, so there is a terminology called that one. So it is like we have a gullak, right? We store the money into the gullak, and later if you want to use, you can take out the money. Sorry? MetaMask is another wallet. It is it uses in So, okay, if I will recall, I will tell you, okay. So, what happens in Ethereum also, it takes certain minutes, okay. So, Ethereum is little bit faster than the Bitcoin. And then we have a private blockchains right now, and they are nearly real time, but not the actual real time. The real time is you have UPIs, right? You scanned and you transferred the money. Once you transferred money, at a time money will get transferred to the consumer, okay? But in a Bitcoin, it doesn't happen. It goes to, so you remember the value, the name? Where it gets stored in between, the wallet. Okay, I will remember, I will tell you, okay? Okay, then we'll have the last one. So we'll calculate the energy loss that happened in the process. So how much you injected energy into the network and how much is delivered. So you can calculate the energy loss, and you can check the threshold also. So we'll check the threshold in our smart contract, how much, what is the threshold. If threshold is, suppose you have set the losses for 5% and the losses is happening more than 5%, you can check the meters or you can check the wires, and you can check the, you can take the action basically to reduce the energy losses, okay. So this all will happen through the smart contract here, okay. IPFS, I told you why we need IPFS in this one, okay. This is the smart contract event that will happen. Okay, this is the case study that I was talking about, okay. So the first one and the major company in this field is Power Laser. They have a project from UP government also. They have given around 300 crore rupees for this one, okay. So this Australian company Power Laser, they are building this system, the one I was talking about in UP, okay. So basically they have developed their own blockchain. They are not using the Ethereum or they are not using the Bitcoin, okay. They have their own consortium blockchain. They have the other things are same. They are using POS, and the system they have designed, the first system they designed is around 120 household they taken as a pilot project, and they developed this one. And right now the trading size is around 50 to 100 kilowatt per day, okay. And they are saving around 15%, 15 to 25% on the bills. Suppose we have, I don't know the price unit of the electricity here. So suppose it is 10 rupees per unit, okay. So by using this one, the renewable energies, they have reduced around 15 to 25% of the total billing, okay. They have presence into the 8+ countries. If you want to get into more details, so there is a paper called white papers. You people know white papers? What is the white papers? If people develop some technologies, the startups, they have white papers. In a white paper, they clearly mentioned everything, what is their roadmap and what kind of technology they are using, okay. So go to the website of Power Laser and you can check the white papers of this company. And then we have another one, it's called Brooklyn Microgrid. I have been here for a month. So they have proper setup, okay. They are their setup is not into the households. When I was there, they had the setup into a factory basically, okay. They did their setup into the factory and then they moved to the around 60 households. They are basically fully dependent on the solar panel. And then we have a Tata Power. So they are still into the consideration phase. This is not on the ground. So they have built a consumer nodes of 150 plus, and the installed capacity is 5 megawatt distributed, but they are not fully peer to peer. They are centralized, okay. They are buying the energy from the people and they are distributing by their grid. They are not doing peer to peer between the consumer and prosumer. They are doing peer to peer between prosumer to grid and grid to consumer, okay. And this also they have reduced the losses, but not the losses the one we wanted, okay. The company we have working for this one is India Smart Grid Forum and Power Laser. Power Laser again the same company, Australian company. Okay. So if you people want to open a company, then this is a solution. Okay, this is the problem and you can find the solution by yourself. Then we have another company. This is the very big company, V Power. So it is basically in Spain. They have 39,000 megawatt productions. Okay, and they are fully peer-to-peer. They have created their own tokens also, and they are into the market and they are doing pretty well. Okay. And this is another one called Electrify. So this is Singapore based company. They are also on the ground. They have built basically this is the first company that has commercialized these things. Okay. They have commercialized Nerdy marketplace, and basically this is built, they have built it on Ethereum. Okay, so can anyone tell the problem like the one we discussed? Okay, so the implementation can be done on a blockchain. So what will be the problem that we can face? So there will be certain problems, like not certain, there will be many problems. So try to think of few problems and try to share. So what can be the problem for this one, to implement this one? So you know, right, the blockchain is not regularized in India. The Bitcoin basically, the cryptocurrencies. So the first one will be the regulation, right? And tell me the other ones. So any other problem you can think of? The scalability, right? Sorry? High throughput. High throughput we need, that's not a problem. Low throughput is a problem, right? We have low throughput. Okay. Any other? We need a real-time settlement. We don't have a real-time settlement in the existing blockchains. Energy consumption will not be more if we are going for the private one. Larger the database. You don't need to store the database here, larger database, because we are not, this is kind of, suppose we are not maintaining the UPI transactions, right? You don't need the transactions. Like too much, like you can maintain for a 3 months or 1 month, you don't need that larger data here. So the main problem is policies problem, okay? Suppose you have built a village on this one. You have around 100 households, okay? And in that 500 are producing the energies and other 500 are the consumers. The 500 is the prosumers. But you cannot guarantee like those 500 prosumers that they can feed the energy to other 500 customers. It cannot be same exactly, the amount of energy that you are producing and the amount of consumption that is happening. So what will happen in that case? You will go blackout or you will find another solution. What is the solution? You can involve the utility companies like we have Reliance Power or NPCL. Okay. There is one more problem here. You know the energy, in this one you need a bidirectional energies. So how you will transfer the energy in bidirections? You have a transformer, right? Step up transformer, step down. In first year you have read, right? We have a step up transformer, step down transformer. So 11,000 volt comes from the main line and you get 230 at your home. So how you are gonna do this one 230 230 to your neighbor, and at the same times you need energy from the utility company also. And the problem is, if it is decentralized, who is going to maintain the network? There is a blockchain network that also needs, sorry? No, that is the one you are saying, the decentralized one, that is okay in a Bitcoin case. But in our problem, we have a small village only, right? And you are creating a blockchain network for them. Suppose you as a company, okay, you are creating a blockchain network for them. You cannot maintain because you will not get a money out of that, okay? If you are maintaining that one, that means you are controlling the network. You need to make it decentralized. Who is going to pay for the maintenance of the network? So there comes, you need a consensus mechanism of your own. Okay, the first one, the first problem and solution. You need consensus mechanism of your own. And another one, for if you are building, you are doing a transactions, right? So you can make a minor nodes also. Basically, you are building a consensus mechanism. You need to make a minor nodes. Any kind of algorithm that you use, consensus algorithm, you need to make some minor nodes. Okay. So for every transaction, you can get a fees, 1% or 2%. Okay. That you can charge for every transaction, and that you can use to maintain the network. Okay. That is not practically have been done. So this is the solution that that was in my paper, the one I said, the one I am telling you. Okay. So we have a regulatory problems. In India it is not too much. So India, they don't have any regulations for that. But in European country you can see. So there is a European Union, and then we have USA, Singapore, Japan. They have all the regulatory plans for this one. Okay. Because people are trying to move through from the non-renewable to renewable energies. Okay. So let's remove the PhD here and let's go to you people are BTech students. Let's go with the BTech. Okay. So in a final year project, you people are in final year, third year. Okay, next year you will build a project, right? So you people can build a project on this one. So there are basically all 4 problems can be done by a single groups, like single group, one problem, one like another group is another problem. You can build this one. Okay. So the first one is you can build the whole system, the one I talked, like the one I said. Then you can introduce the AI also for predictive learning or for the auction mechanism into the system. And then you can create a carbon market, the another problem I said. So for the carbon markets there is another blockchain solution. And then you can do the smart metering. Okay. So for privacy preserving smart metering. And what we can introduce is in this one. So all the real time problem, all the real time case example that I said, so most of them are on Ethereum, or they have built their own private network. Okay. On a ground, reality is little bit different. On a ground, people are not using this one because they don't have any real time solution. As I said, the blockchain, the problem is even Ethereum is not real time. Okay. So that's why people are trying to move POS into the Ethereum. Once it will be done, then transaction will become faster and it will come into the market. Okay. So even the Indian government, Tata company is also building this one. Okay, this infrastructure, and hopefully we'll see this one in India. Okay, in a real time. In IIT Kanpur, they have a smart grid, okay? They are trying to build a, if you people are going there for industrial visit, you can ask your sir also. So there is a smart grid there. They have their own smart grid, and they have implemented basically blockchain into that, okay? But on what level I don't know, cause I have left IIT almost 3 or 4 years back. But they were working on a blockchain into the system, okay? Okay, so tell me what, if you want to introduce AI also in this system, so what AI can do in this one? Basically what AI do? We have a prediction, we have a clustering, right? There are two things only AI do, either prediction or clustering, okay? So we can do the load forecasting, the prediction, EV charging optimization. You can do with the machine learning algorithms. We have a price elasticity prediction, the fault anomaly detection. Now this one we can do. So the one we are saying about, like there is a fault in the system and there is a, suppose we have taken the threshold of 5% energy loss is okay, not more than that. And if we need to take any action, then AI can help to find the problem, actually what is the problem in transmission line, okay? Okay, if you want to build a blockchain one, so we need a low latency blockchain and we need a low computational load of blockchain for this one, and we need a high throughput. So for now we have all this property in PBFT, but that is not enough for a real time one, okay? Okay, I will leave this one. Have anyone heard the cross chain? The cross chain tokens? Okay, what is a cross chain then? Cross chain, cross chain. It happens in a blockchain actually. We have off chain, we have a cross chain, we have a side chain, we have a blockchain. All the terms are for forking. You know the soft fork, hard fork? No? This is the main network, right? The main blockchain network. And they are connected. Sometimes if they are adding a block, they will add a block here and they will add another block here. Okay? And the block that will go longer will be valid and other will be obsolete. So this is the forking problem. Okay, that this is very common in a blockchain, in basically the main blockchain. Okay. So sometimes we intentionally build this one, the cross chains, on a blockchain. Okay, to reduce the load on a main blockchain. And these are the things that can help in our system, the one we are trying to build, peer-to-peer energy one, okay? And we have another things that is called the CBDCs. Anyone knows about the CBDC? Sorry? CBDC. No? Central bank digital currencies? No one knows? Okay, I am not sure, but almost 1.5 or 2 years back, there was a message from HDFC, ICICI and Axis Bank about the CBDC, a text message on mobile. Anyone remember that? No? So, you know people, this Digital India, right? Modi in Digital India, he was trying to promote the digital, like the digital transactions, right? So on that theme, some banks they initiated the CBDCs. We call the central bank digital currencies. This will be controlled by the RBI. So you have heard e-rupees? No. What is e-rupees? That is CBDC. Okay. So there are two types of currencies that I will share. One is fiat currency and one is crypto digital CBDC, okay, RE currencies. So what is the fiat currency? Sorry? The notes, the one we have, the coins are called the fiat currencies, okay? So when he said like we'll make a corruption Mukt Bharat, okay, so he was trying to go on the digital currencies. So I'm sure they will not implement that, but yeah, for saying they have done this one, okay. So this CBDCs is built on a blockchain. Actually not on actual blockchain, but on the concept of blockchain, okay. The RBI will control everything and they can track down all the money that they are putting into the market. So the black money kind of those things that will go obsolete, okay. Suppose you are doing a job, you are getting salary of 1 lakh rupees, okay. That 1 lakh rupees you cannot take it out, that is digital money, okay. The value will be same, 1 rupee equal will be 1 e-rupees, but you cannot take out that money. You cannot have a fiat currencies. It will be a e-rupees, and you can read about this one, HDFC and Axis Bank and ICICI. I think these three. One more bank they have introduced. I don't remember the name. I think it is Bank of India. I don't know the fourth one. It is not SBI. Okay. It is the private bank. So they have introduced this one and you can read about that one. किसको? Banking system में? You cannot apply. Theoretically you can. Theoretically everything is on a every banking system is on a blockchain, but practically bank will not share their data. बैंक कोई भी data share नहीं करता public में. ये उनका स्ट्रेटजी है, राइट। आपका सिग्नेचर मिसमैच होता, आप बोल दो कि मैं ही हूं, एक बार दिखा दो, मैं दोबारा से कर दूं, नहीं दिखाएंगे, राइट। तो बैंक नेवर शेयर द डेटा। तो आप ब्लॉकचेन को इंप्लीमेंट कैसे कर सकते हो उस पर, जबकि पूरा बैंकिंग सिस्टम यू कैन बिल्ड इट ऑन अ ब्लॉकचेन एंड इट विल बी मोर एफिशिएंट देन द बैंकिंग सिस्टम्स। You don't need to do the KYC every time. You don't need to change the number and go to the bank. You don't need to maintain the passbook, and you don't need anything. Okay. RBI will govern the data. They will have all the data, and you can maintain all those things. Okay. But they will not do this one. Okay. With that, I think we'll move to the hands-on. Any question regarding the implementation or the concept of the blockchain? Anything about the blockchain if you want to ask so far? Any question? Or we can move to the hands-on. We'll have a little break and then we'll move to the hands-on. Mempool, that is for the cryptocurrencies, the one we build. Cryptocurrencies, we build our tokens, right? As I said, once you launch the tokens into the market, then we build the meme pools. See, the Bitcoin they don't use, okay, the Ether they don't use, the crypto, we have a lot of other cryptocurrencies, right? They don't build on a mainnet, they built on a side nets, basically on a off chain or a cross chain or side chain. So they don't do the transaction, real time transactions. Okay, you did a transaction, I did a we both did a transaction. It will not go to the mainnet. It will go to the pool. There will be certain transactions that will happen there. They will collect all the transaction and they will make a single hash value out of that, and then they will store that on a mainnet. Yeah, basically in a off chain. Okay, so that's what mempool does. Okay. In a Bitcoin, yeah, yeah. It doesn't go to the mempool. It is basically into the process, the one we. That's what I said. I am not able to recall that word. Hmm? It's mempool, but we call different this one. It's mempool does the same work, but in a cross chain, in a off chain. Mempool does same work, but in a mainnet it is some other word that is said. The same work mempool does to store a transaction for a certain time. The same thing does in a mainnet to store certain, like to store transaction for certain time. Okay. Any other question? Or we can wrap up this theory session and we'll move to the hands-on. Okay. So how we'll do the hands-on? You people have a laptop? Everybody? Okay, we'll have a 10-minute break and then we'll do the hands-on. Okay. We'll start at sharp 4 o'clock. Okay. बजे हमें फिनिश करना है, आप लोग 5 बजे बस होती है और 1 घंटे हमें हैंड्स ऑन में चाहिए. ओके, बट अभी हमें कितना देर रहना है? 7-8 मिनट. तो आप लोग कुछ भी पूछना चाहें तो 7-8 मिनट या फिर चुप रह के बैठ सकते हैं. बट आई विल सजेस्ट कि इतना रिसोर्सेस यूज किया गया तो कुछ भी पूछिए रिलेटेड टू बिटकॉइन, ब्लॉकचेन, एनीथिंग, एनएफटी, सीबीडीसीज, एनीथिंग. डेटा बैंकिंग डेटा नहीं दे रहा. आप जनरेट कर सकते हैं ना डेटा, जनरेट कर सकते हैं डेटा. सब एआई टूल्स हैं, सारे एआई जनरेशन के. या आप डेटा बेसेस होते हैं, जैसे बड़े बड़े डेटा बेसेस हैं, वो अपने डेटा रिलीज करते हैं पब्लिक रिसर्च के लिए. इवन बैंक्स भी डेटा रिलीज करते हैं, वो रियल टाइम डेटा नहीं, वो ओल्ड डेटा, डिस्कार्टेड डेटा वो रिलीज करते हैं रिसर्च के लिए. इंडिया के बैंक नहीं करते हैं, यूरोपियन वगैरह करते हैं कुछ. तो आपको डेटा बेसेस होते हैं, केगल डेटा बेस है करके, एलसीए डेटा बेस है. ये डेटा बेसेस से आप डेटा उठा सकते हैं. आप उन डेटा पे रिसर्च, किसी भी फील्ड का डेटा, हर फील्ड. इंडियन बैंकिंग सिस्टम जनरेट कर सकते हो आप चैट जीपीटी से या फिर अलग एआई टूल से। तो आप देखो सर्च, क्योंकि देखो आप बैंक तो डेटा देगा नहीं, बैंक तो डेटा देगा नहीं, नहीं देगा, कोई भी बैंक नहीं देगा आपको। सब सिंथेटिक डेटा पे होते हैं सब। रियल टाइम डेटा उठाना है आपको तो अदर बैंकिंग सिस्टम उठाओ, इंडियन बैंकिंग सिस्टम में। जब आप पेपर पब्लिश करते हो, अगर आप हाई इम्पैक्ट जर्नल्स में पब्लिश करना है आपको, तो आप ये नहीं उठा सकते हो इंडियन बैंकिंग खाली, आपको फिर उठाना है ग्लोबल बैंकिंग का। ग्लोबल बैंकिंग में आप डेटाबेसेस पे जाके देखो, एलसीए पे जाके देखो, आप केगल पे जाके देखो, उस पर डेटा मिल जाएंगे आपको। फॉरेंसिक्स में ये अब एक बार मैंने डिस्कस किया था किसी ट्रिपल आईटी के प्रोफेसर से, वो उस पर काम कर रहे थे। ट्रिपल आईटी दिल्ली में है वो। ये सब ब्लॉकचेन का पार्ट है ना, इससे आपको कोई लेना देना नहीं होना चाहिए कि आप बिटकॉइन पे कर रहे हो, इथेरियम पे कर रहे हो, हाइपरलेजर पे कर रहे हो, आप किसी भी चीज पे करो। देखो बेसिकली क्या होता है, जब ब्लॉकचेन पे आप कुछ भी स्टोर करते हो वो डेटा होता है। फॉरेंसिक में आपके पास कमोडिटीज होती है। कमोडिटीज जब आप लेते हो तो आप रिसीविंग लेते हो हर चीज का। आप बोल रहे हो ना चेन आपका स्टडी करना है, तो बेसिकली हम सप्लाई चेन पे भी काम किए हैं, तो उसके रेफरेंस में बताते हैं, क्योंकि उसमें भी है ना वेंडर टू वेंडर, वेंडर टू वेंडर। तो आप वेंडर हटा दो, आप अपना पर्सन ले लो उसमें, ठीक है। हाँ, पर्सन टू पर्सन हर एक पर्सन एक नोड है आपका। कंप्यूटर के लिए तो नोड है सारे, ठीक है। एक पॉइंट है, नोड पॉइंट है, ये नोड से ये नोड डेटा, ये नोड से ये नोड डेटा, ये नोड से ये नोड डेटा, वो सारा कुछ आपको ब्लॉकचेन पे है। देखो होता क्या है, जो सामने वाले लोग हैं उनको ब्लॉकचेन से कोई लेना देना नहीं। आप सिस्टम बिल्ड कर रहे हो, आप उनके लिए यूआई बनाओ। उनके लिए यूआई बनाने का मतलब है जैसे अभी करते हैं, क्योंकि अभी भी तो सर्टेन मैनुअल एंट्री तो करते ही होंगे या कंप्यूटर पे एंट्री करते ही होंगे, वही आप यूआई उनको बना के दो। जो वो एंट्री करें वो डेटा ब्लॉकचेन पे सेव होना चाहिए, रादर देन गोइंग टू सेंट्रलाइज डेटाबेस। बस इतना करना है आपको, सेम प्रोसेस वही करना है। अगर आप वो बिल्ड नहीं कर सकते तो आप जनरल पब्लिक के लिए नहीं बिल्ड कर सकते हैं कोई भी सॉल्यूशन। हाँ, तो आप काम करते हो इस पे, फॉरेंसिक्स पे? ओके ओके, फॉरेंसिक्स पे। चेन ऑफ कस्टडी में आप पीएचडी टॉपिक थीसिस नहीं कर सकते हो, क्योंकि आप उसमें देखो आप, मैंने भी इम्प्लीमेंटेशन पे किया था। जो मेरी पीएचडी थी, मेरा यही था जो अभी मैंने बताया, पीयर टू पीयर एनर्जी ट्रेडिंग, जितना बताया यही पूरा पीएचडी था मेरा। बट मैंने इम्प्लीमेंट किया था ये 2019 में किया था, तो पीएचडी मिलती थी उस पर, क्योंकि हमने पूरा सिस्टम बिल्ड किया था इंडिया में, चाइना में, चिंगुआ से मिल के कोलेबरेट करके मैंने पूरा सिस्टम बिल्ड किया। वो मेरी थीसिस हो गई। आज के टाइम पे आप उस पर पीएचडी नहीं ले सकते जिस पे मैंने लिया है। इसमें आप नया क्या कर रहे हो, क्वेश्चन ये है, आप तो इम्प्लीमेंट कर रहे हो। हाँ, वो तो आप ट्रेसेबिलिटी में चेक कर सकते हो, कहाँ पे ब्रेक हुई है, किस पॉइंट पे ब्रेक हुई है, वो आप चेक कर सकते हो। वो ट्रेडिशनल डेटाबेस में भी तो होता है कि कहाँ पे ब्रेक हुआ है, कहाँ से नहीं पास हुआ है। बस इसमें फ़ायदा ये है कि आप बाद में चेंज नहीं कर सकते हो, जो हो गया वो हो गया, टेम्पर प्रूफ हो गया। प्रॉब्लम यह है कि आप इसको पीएचडी थीसिस में जस्टिफाई कैसे करोगे। अब मुझे यहाँ का नहीं पता, बट आप आईआईटी कानपुर में, अच्छा ओके। तो अब जैसे अब हम आईआईटी कानपुर में, अगर हम ये बताएंगे ना, ये जो प्री थीसिस सबमिशन होता है वो 1 साल बाद जो होता है, उतने तक खत्म कर देंगे इसको। अब इसके बाद कुछ करो इसमें, अदरवाइज नहीं होगी, ठीक है। फॉरेंसिक्स का तो हमको आइडिया नहीं है, आप बेटर काम कर सकते हो ना। अगर ब्लॉकचेन पे काम करना है, कंप्यूटर साइंस बैकग्राउंड से हो, कोडिंग आता है अच्छे से, तो आप कंसेंसस पे काम करो फिर, बेसिकली फॉर मेडिकल फील्ड। अगर आपने एक भी कंसेंसस डेवलप कर दिया, कुछ भी डेवलप कर दिया, थोड़ा सा डिफरेंट, आपकी अच्छी पीएचडी भी हो जाएगी और उसके आगे भी रास्ते अच्छे हो जाएंगे आपके मेडिकल के लिए। बेसिकली मेडिकल के लिए भी तो आपको रियल टाइम चाहिए, रियल टाइम चाहिए, क्योंकि वहाँ डेटा सेंसिटिविटी ज़्यादा है। जैसे तीनों प्रॉब्लम मैंने बताया ट्राइलेमा का, डिसेंट्रलाइजेशन, स्केलेबिलिटी, सिक्योरिटी। आप डिसेंट्रलाइजेशन कम कर सकते हो, बट वहाँ सिक्योरिटी हाई चाहिए आपको। बिटकॉइन में क्या है, आपको बिटकॉइन में डिसेंट्रलाइजेशन फुली चाहिए, सिक्योरिटी फुली चाहिए, इनके पास स्केलेबिलिटी नहीं है, तो आपको सिक्योरिटी ज़्यादा चाहिए। ठीक है, सिक्योरिटी चाहिए, स्केलेबिलिटी चाहिए। डिसेंट्रलाइजेशन से बहुत मतलब नहीं है, 10 डॉक्टर के पास रहे, 12 डॉक्टर के पास रहे, क्या फ़र्क पड़ता है। ठीक है, डॉक्टर से अपना कर लेंगे, आपको कंसेंसस पे काम कर सकते हो। और रही बात पेपर के लिए, तो आप वो पेपर के लिए कर सकते हो, जो आपने फॉरेंसिक चेन ऑफ स्टडी बोला, पेपर के लिए आप कर लो, बेटर है, बट नॉट फॉर पेपर। तो आप आज के टाइम पे किसी पे भी कर सकते हो पेपर, बस छापो कैसे भी। हो गया टाइम ब्रेक का? नहीं, ब्रेक का हो गया टाइम।